everyone. Thank you so much for attending another edition of the ISI Natural Language Seminar. We are very grateful to have Da Yin from UCLA here to talk to us about weekly supervised learning for adaptive LLM agents. Da Yin is a final year PhD student in computer science at UCLA, advised by Professor Paiwei Cheng, working in the UCLA NLP lab. He was awarded the Amazon PhD Fellowship and Best Paper Award at the MNLP Pan-DL workshop in 2023. He was also the co-organizer of the first ACL MML workshop, publicity chair of the fourth SoCal NLP Symposium, and area chair at ACL ARR from 2023. His research interest is building generalizable, adaptive, and inclusive language processing models that can be applied across applications and regions. Thank you all so much for being here, and please welcome Da Yin for his talk.
So first, thank you so much for introducing me and Katie. So hi everyone, my name is Da Yin. I'm a final year PhD student at UCLA, advised by Professor Paiwei Cheng. So it's my great honor to be here to see all of you guys and also share some recent progress about my recent work about like large language model agent training. And so today my talk will mainly focus on one of the kind of like the important directions I think for the future agent research, which is called weekly supervised learning for adaptive LLM agents. So before I talk about more details about my talk, so I will first give you some background knowledge about the LLM agent. So actually the language agents are usually required to follow the user's natural language instructions and to finish some very complex tasks. And usually the tasks will cover like two main characteristics. So the first one is that the tasks usually have high complexity, that is multi-step planning and reasoning. And the second characteristic is that so usually the task will involve an additional like real world or simulated environments for the interaction. And then the agent needs to learn how to plan, how to interact with the external environments, and then to finish the task. And then I will give you some like task examples to show how the task will look like and how what the agent usually do to finish the task. And here is kind of like a typical web agent task from a very famous benchmark called My2Web. So here the task instruction is about booking a rental car, and also the task environment is real like HTML like zip car web interface. And what the agent will usually do is that they will first get the web interface of the Zipcar main page, and they need to know in the first step I need to fill in some like important information. For example, I need to fill in the car rental city. For example, in these instructions we mentioned the rental city will be the Brooklyn city, and then the agent needs to get this kind of information and fill the key information in the relevant like elements or the bounding blocks. And then after they fill in the city information, they will realize, I have several things to be done. For example, filling the pickup date and also some other informations. And then I will do the click on the search element. And then, after doing all of this, maybe there will be some like car options will appear, and then the model will look at the original like task instruction and also the options the website provides, and to pick up maybe one of the relevant like Toyota Corolla like car, and they will do this kind of like things repeatedly and until the task is finished. So this is a kind of like a typical example for the web agent task, and also right now besides the web agent tasks, so there are many like new like agent evaluation benchmarks, and they become more and more realistic and involve many different domains. So previously, we constructed a virtual environment that simulates the daily like office workflow system in a Docker, and we also constructed a benchmark to assess how well the current large language model agents can automate the workflow, which involves the planning and reasoning over multiple apps. So this is our benchmark. And there's another, so this is a more like general purpose and more like famous agent evaluation benchmark, which is called OS World. So actually the OS World will incorporate a real like Linux or Windows virtual machines as an external environment. And actually for this task, the agent needs to perceive the current system interface, understand what is in the interface and what they need to do in the current step, and then they will do very long horizontal planning, grounding, and also reasoning accordingly. Okay, so although there are so many like agent evaluation benchmarks right now, the new agent evaluation benchmark will always coming in. But what can we do to improve the agent performance to perform very well on this kind of like agent benchmarks? So actually one intuitive way is that, okay, so we can ask for some expert annotators help to annotate a bunch of very large number of like training trajectories. However, if you have many resources to spend, so it's definitely possible. But I need to remind you of a fact mentioned in the original like OS World paper, is that it is said that actually they construct the virtual environment and also annotate just 300 tasks for around like 1,800 human hours. So that is pretty like expensive.
Yes, to do the task and also to label each step.
To label each step. And also they need to kind of like write the evaluation script to evaluate, okay, if the task is finished or not. Because actually you cannot use kind of like automatic script to judge, okay, if the task is finished or not. Okay. So you need some human efforts to write the evaluation script to do the kind of like the validation, something like that. So I think the whole the effort is pretty huge. Or maybe you can think of so actually on the other hand, so maybe you can think of some ways that maybe it's not a very big issue for the big companies like Apple. So actually Apple can recruit a lot of like annotators to do the trajectory annotations on their own like iOS or Mac OS system. But here I want to argue that there are always more and more like complex agent tasks which will far beyond the scope of the iOS or Mac OS environment. And so this paradigm can't be kind of like a sustainable paradigm. Because you can't recruit many kind of like annotators for each of the new like agent evaluation benchmark. And also I'm thinking about an example, like if you want to ask the agent to do the machine learning research from scratch, so it might not be like practical because it is very hard to recruit a lot of like PhD students to record every action, every their research like situation across the whole like the research process. So that would be very expensive and impractical. So if that is so overall, so not just for the current benchmarks like OS World and Office Bench, but also we can imagine that there will be more and more like new agent evaluation benchmarks with higher complexity and involving completely new environments, completely new domains, and without too much training resources. So here is the main research question we want to address here in this talk is how to train the large language model agents to adapt to the environment without too much training supervision. Okay, to address this question, so during my last and this year, so I explored in multiple different dimensions. So first, I will introduce the Agent Lumos, so which is one of the first unified open source and the general purpose agent training frameworks that helps that teach the LLMs to learn how to plan, how to interact with the external environment, and how to generalize across diverse scenarios with some unified training method. And actually, the Agent Lumos is mainly about training like a foundation like agent policy model that has the basic planning and reasoning ability and some limited like generalizability. And in the next step, so we want to put such kind of like trained agent policy models in the unseen environments and let the agents to collect some like experience in the real like unseen environments and learn from the feedbacks from that environments. And for that part, so I will briefly talk about two papers. One is trial and error, and the other one is Q-star agent. So which will this kind of like two methods will encourage the large language models to do the self exploration in the unseen environment and learn from the feedback from the environment. And in the end, so I will discuss several like key future directions and also my ongoing work, which will be kind of like important for the future agent research. Yeah, for effortlessly training the adaptive like LLM agents. Yeah, for such as like agent critique and word models. Okay, so maybe we can start from the Agent Lumos paper, which tries to enhance the agent adaptability by the unified training. And actually, this is a joint project with the AI2 Mosaic team and was accepted at ACL 2024, and it already got maybe over like 400 GitHub stars right now. Yeah, and our research goal for this paper is that we want to build one of the first open unified like agent training frameworks for a wide range of complex interactive like agent tasks. And we want the agents to learn how to plan, how to do the right call for the two step by step with some suitable like agent architecture. And so as I mentioned before, so if our goal is to train such kind of like general purpose and unified agent model, so we first need to think of what can be unified for the diverse types of agent tasks. So here we will first take an example about the multi-model reasoning to see how it works and if it motivates our like the agent framework design. Yeah, so suppose we have a let me see. So suppose we have an image and there's a girl with a Nintendo device in her hands, and to answer the question like the device in her hands is from which country, so in a kind of like a multi-hop reasoning like settings, so we first need, so the agents should first need to call the VQA models to recognize the device brand in her hands, and then after we get kind of like some feedbacks from the VQA models, for example, like Nintendo, and then we will use another kind of like QA tools to help us to kind of like to locate the final answer like Japan. So yeah, so this is a kind of like the general process. And also for the web agent tasks, so there will be the similar things will be very important. So for example, given the initial state, we need to first plan our first stop goal. For example, when we see this kind of instruction, we first need to know, okay, we need to first type the Brooklyn as the location for renting the car, and then we will after we get the sub goals, and then we will ground it to the actions, the executable actions, like some click and type, actions, and then we will have something to implement this kind of actions, and we will get a new environment state. And after we get a new environment state, so we need to, based on this kind of new state, to do the next sub-goal planning. And we will do this kind of plan, ground, execute iteration again and again until we finish the task. So with a careful look at more task examples, not just limited to the web agent task or the multi-model reasoning task. So actually we find that this kind of plan, ground, execute pipeline, is kind of widely existing in almost all the agent tasks. So based on this kind of attributes, so we've designed the following Lumos framework, and I will introduce the framework in detail. And so this page shows the overall structure of the agent of our framework. So we have three separate modules. So the first one is the planning module. It is designed for generating the high level sub goals. So here, given a testing instruction about asking the device in your hand is from which country, and the planning module will help us to generate the first subgoal to solve this question. For example, to identify the brand of the device. And after that, so after we get the first subgoal, so we will have a grounding module which will receive the first natural language subgoal and map it to the executable actions. So for example, the executable actions which is grounded here will be calling a VQA model to answer, okay, what is the brand of the device in your hands. And here I also want to, and after you get the executable actions, and then we will call some tools in the third module, the execution module, to really help us to get the answer. Yeah, so for example, so here I want to emphasize that the tools in the execution module can be any version of the VQA models. And yeah, so after you use the VQA models like Lava to answer the question, and then we will get the execution results, or you can see it as a new environment state, which will be the Nintendo. And then we will kind of use this kind of execution results to feed it back to the planning module to help us to do the next subgoal planning.
So from the input is the image and the device in your hand.
Yeah,
and the plan is identify the brand of the device. That's
yes.
the first top.
Yes.
I'm surprised that you I would think there would be more of a kind of breaking down first, which is to say figure out what the device is.
I see.
And I mean, this is an example, I know, but I'm wondering whether it seems to me the way you describe it is it's sort of like a one-shot.
Yeah.
Step. Is that in general how all this is going?
Yeah, I think it's in general. Yeah, this is
one shot.
Yeah, this I don't think it's one shot. So I think this is a kind of after we trained our the Agent Lumos model. So if we want to apply the Agent Lumos model on this kind of question, so the main inference process will be something like that. But I don't think this is just one shot to prompt the model to learn such kind of process.
But I mean, I point in this example, there's one subgoal, and then you're done.
Oh no! So actually, we have more subgoals. Yeah. So this is the first subgoal. Yeah. So after you get the execution results, so you will do the next subgoal planning. For example, you will get answered. Yeah, exactly. So after you do this kind of like iteratively, so you will finally got the final answer with multiple tools, working together. So
good question. So in your planning module, the goal to answer correctly, during training, when the model was on train, so the device in her hand is from which country? So during the early training stage, the goal here should be find the country of the device instead of the broken down sub goals of sub goal one. Okay, first brand of the device and then country of the device. So basically, what I'm saying is during every training, the sub goals generated by your planning module might not be groundable in actual actions that you have, and because and then the model learns that actually it needs to come up with sub goals that are groundable.
Actually, we are trying to guarantee that the subgoal will be groundable. So when we are trying to synthesize the data allocations for training the Lumos, so we are trying to based on some existing chain of thought reasoning, and we guarantee that the chain of thought reasoning in some existing data sets will be groundable will be kind of faithful to the image. So if we use this kind of faithful resources to construct our Lumos training data, so we believe that the Lumos will also learn to generate some faithful subgoals. So I believe for other models, so it doesn't have this kind of unfaithful problem.
So if we take out the visual component, this actually starts to look like a lot of tasks that have already been very well explored in the NLP literature, like multi-step question answering, hot QA, a bunch of these tasks where you just need multiple documents or interleaving queries.
Yes.
So can this just be seen as a generalization or a superset of these tasks?
I think we are trying to do a kind of superset, and I think another key thing is that maybe for the traditional multi-hop QA or QA maybe tasks, so they are not trying to do kind of some true usage component. So for example, maybe they are trying to use their parametric knowledge to directly answer this question. But actually, because we want to build kind of a unified agent framework, so the agent task will far beyond the multi-hop QA tasks. So, but we also think that multi-hop QA should also be similar, to some other agent tasks, which will use a lot of additional tools or actions. So we are trying to kind of integrate this kind of multi-hop QA into the two usage scenario we will focus on for the agent Lumos usage. So this is our goal.
Hi, I was wondering how you provide supervision of the high level.
I will talk about that. Okay, so I think this is a unified pipeline, and this is how the Lumos will solve this problem. How the Lumos agent formulation will solve this problem, and then we will look into some details about the formulation design. So previously, I just mainly take a multi-model reasoning task as an example to show how the Lumos will work. But actually, the Lumos can be a very general agent framework, as I mentioned before. So other agent tasks, including multi-hop QA, math reasoning, and also web agent tasks. So actually, they all share this kind of plan, run, execute iteration for the problem solving. And if the framework can be applied to any agent tasks, so why not train a unified agent model with the allocations across different domains to learn more adaptive and more robust planning ability across different environments? So actually, there are some prior successful cases like unified SKG and unified QA. So actually, they try to unify the tasks with very diverse formulation, but sharing the similar solution skills. And we believe that for our by unifying different types of like agent tasks, we can also achieve this kind of like generalizability across some very diverse like environments and tasks. Yeah, so and also for the architecture, so previously we showed that we want to separate the agent framework into like modules and build a modular agent. And one of the reasons for adopting the modular design is that maybe it is much easier for the agents to learn the skills if we disentangle the planning and grounding skills, and just let one single module to learn just one specific function. And the collaboration between the modules can also bring very competitive results. And also, I think the modular framework can be more debuggable and upgradable. So with a modular framework, so we can individually like evaluate each module, and we can easily locate where the problem is and fix the problem very easily. Okay, and after we decide the agent framework or agent architecture, so how can we get the annotations for training the planning and grounding module? Yeah, so actually we know that there are many like open source data sets which have the annotated chain of thoughts like reasoning rationales. So why not we just leverage this kind of like naturally existing like annotated reasoning rationales to scale up the data amount while also maintaining the data quality. But another problem is that, okay, so there are too many like data sets which will have the reasoning rationales, and the format of them will be kind of like very diverse. And how can we, what can we do to unify their reasoning rationales into the unified format we want to align with our Agent Lumos framework? So here we will propose a prompting-based data conversion method to convert the reasoning rationales with diverse formats into a unified format with kind of like sub-goal-based plans and executable like actions. So here with kind of like some like a few short in context examples. So GPT-4 is very helpful to convert any like reasoning rationales in any format to the unified style we want. So finally, we will produce the converted annotations like this. So the upper part will be the original like unstructured like reasoning rationales, and then we will use the GPT-4 to do the style transfer, and then we can get the annotations below. This is a converted annotations. So first we can get the sub goals. The sub goals from the already like allocated like ground truth reasoning rationales, like sub goal 1, sub goal 2, sub goal 3, and then we will and under each sub goal, so there will be some like low level executable actions, which is corresponding to the sub goal, or which is kind of like very helpful to implement the sub goal, the model generated. And then we also have the execution results. So the execution results is usually in the last like low-level executable action. So which means that the execution results will be the final execution results for the whole subgoal. For example, the 46 years is the execution results for the subgoal 1, and the 75 years will be the execution results for the subgoal 2.
So with this formulation, when OpenAI is parsing through the ground truth reasoning steps, it needs to know all of the tools and formats of the tools. Right?
Yeah, exactly. So when we are trying to do the conversion, so we will provide an action interface. For example, what will the action or API looks like, and then we ask them to align with that like kind of like given format, and then they can help us to provide this kind of like structured and valid like actions.
So in your experience, like, do you need GPT-4 to make the format following good? Is 3.5 enough? Like, what What do you use to generate these synthetic data?
I think at that time, so we just have the GPT-4. Yeah, so we have the GPT-3.5 and GPT-4, but GPT-3.5 is it's really bad at this kind of like task. But I believe for some current like stronger like models, like maybe GPT-4o, like or even like much cheaper like GPT-4 mini. So I think they can do this kind of like task very well. So yeah, but you know that the GPT-4 mini is much cheaper than the GPT-4 right now. So yeah, I believe you can use the GPT-4 mini to do maybe to further scale up the annotation conversion process.
Do you have to extract the intermediate results because it's not available in the original document?
Yeah, exactly.
How many tool types do you have?
Oh, yeah, I will show it in the later slides. Okay, so this is the kind of like our how we convert the annotations from the existing ground truth reasoning rationales. And also, I want to emphasize that our Lumos framework is quite kind of like flexible. So you can, for the planning module and the grounding module, so you can use any like open source like large language models. And for the execution module, so currently we support many kind of like tools, including the calculators and also some like domain-specific small models, which will provide more precise answers rather compared to the large language models. So I think our like the supported like models and tools, it will be very diverse in our Agent Lumos framework. And here I also want to show you some like the annotation data sources. So we mainly involve the 4 domains: math, QA, web, and multimodal domains. And also for each domain, so we will also cover multiple different styles of the data sets. Like for math, so we incorporate 3 different math data sets with different difficulty. And also for QA, for web, we have very diverse sources. And also for beyond the sources, so this is the two list. Maybe the screenshot is not very clear, but actually we incorporate a lot of like tools or valid actions in our training data to make sure. So I think given the kind of like the diversity of the supported tools, so it will help the model to more generalizable to use some novel tools or support some novel actions.
So presumably you're checking the generated intermediate tool steps to make sure that they're compliant.
Exactly.
Do you also do type checking on the arguments?
Actually, I didn't. We didn't do that, but actually we manually checked maybe around 20 or 30 examples. I think there's no problem.
Well, so you build up the state, and then like you're also executing the sequence then using the tools.
Yes.
So if you presumably you have times where you get an answer that is like an error type answer, right?
Yeah.
So then, I mean, what's the general approach that you take to be able to figure out why there's an error? Like,
to be honest, we didn't do like automatic like error checking for generating the training data.
So the training data may have like a result which is like, sorry, this is not a.
So actually, I think let's go back to the previous slides. So actually, because actually our like the annotation conversion is based on some existing like rationales, and this kind of like rationales will have a kind of like a definite like answer. So they will not have any like sorry, I don't know this kind of like thing. I can't search. I can't find out this kind of like things. So actually, we just leverage this kind of like. Maybe it's like weak supervision. Maybe this is not the real like trajectory.
You don't actually execute knowledge.
We don't execute. So this is more like Yeah, but I definitely admit that maybe there are some like errors in the training annotation, but I think perhaps right now maybe the data quantity will matter more than the quality. If we look at the quality and filter out some like invalid ones, maybe the data quantity will be much less. And perhaps maybe it will not be a very good strategy to get some better performance on the downstream tasks.
When you have a policy model where you update like the SFD samples based on the multi-sample, they will never be updated.
They will never be updated for the current stage. Okay, so this is our supported tools, and then we'll go to the results like part. And actually the first observation from this table, so actually we first do the evaluation on the unseen task, which will involve a completely new like environment and completely novel like actions on the task called web shop. So actually from this kind of like result table, so we can observe two things. So the first thing is that the Agent Lumos can achieve better performance than many like open source large language models, including some like much larger model like we call 33 billion. So currently, so I think for this table, so the improvement is achieved by the 13 billion like based model. So which is very amazing. And the second observation we observe is that actually the Agent Lumos trained with the unified data will largely outperforms the task-specific Lumos agents, which shows the effectiveness of using the unified training and unified data to improve the generalization. And also beyond the unseen task evaluation, we also do some like in-domain agent downstream task evaluation, and we also see that you can achieve very amazing like results. For example, for the web agent task, which is called Mind2Web, so you can even outperform the GPT-4 like 9%, and also for the multi-op QA, so you can achieve the GPT 3.5 turbo at that time. So actually, GPT 3.5 turbo at that time is very powerful. In 2023. So all the results are very amazing.
So you say Lumos is based on Llama 2. So that's the trained model.
That's
the data that you have.
Yes.
The data itself is from GPT-4.
I think it is not kind of like I think the GPT-4 is just help us to do the conversion, but it's not creates the data from scratch.
The actual decisions are based on Llama 2.
Actual decision is
how much? I forgot this. So how much training data is there for?
I think it's around like 56K trajectories.
56K trajectories. So like for one tool, how many examples of the use of the tool?
Actually we didn't count that.
Approximately.
I think maybe we can approximate that from this table. So maybe for let me see. Maybe for the math, I think so currently we got like maybe 19K 19K whole trajectory, and maybe like most of them will be like some basic like calculation, and maybe some maybe just like 10% or 20% of them will be like set equation, some stuff like that.
Small tens of thousands or thousands. I'm just trying to understand what we train Llama 2 to do, which is to say like you get a natural language text, which is like take the square root of 35, and it's like call from alpha sqrt parentheses.
Exactly. Okay, so I think that's the part for the Agent Lumos. So I will stop here a little bit. So if you have any questions.
For just an case with 2 use, right?
Oh, sorry?
For just an case with 2 use?
With 2 use with accuracy. Oh, what's the accuracy? I think the accuracy is around like 55% on the test set. 55%. Yeah, but actually at that time, I think 55 is already a very high like performance. Yeah, so right now, you know that the current model can do like almost 100% accuracy. Yeah, but at that time, yeah, it's not very good. Yeah.
Is it one round of plan, low level, execute?
Yeah, it's multiple rounds. Yeah, and then sorry.
So like for one question,
yeah,
multiple rounds.
Multiple rounds.
Is it like how does it know when it's done? Like
yeah, this is a very good question. So actually, when we are trying to synthesize the training data, so we will add a kind of like a termination term in the end of the planning or grounding process, and then so in other words, the model needs to self-identify. Okay, I should terminate at that time. Yeah.
Sorry, you're saying GSMAK was 55%, and at the time of ACL 2024, that was very good, but now it's at 100%?
No, I think for the latest GPT model, so they can do.
For 01, you mean?
Yeah, perhaps, yeah. But I think maybe for the open source model, I think, but I think this is for like Llama 3 or Llama 3.
There's a model called DeepSeek.
Oh, DeepSeek, but maybe, so there's kind of like some domain-specific DeepSeek model, like math, DeepSeek. Oh, yeah. So, but you know that, maybe just a 1 years apart, so the model can grow very significantly. Yeah. But at that time, I think the JSON AK performance for our Agent Lumos is quite competitive. Yeah.
So I have a general question. I mean, a lot of these scores are quite low. And I feel like, a lot of my work has shown that like pre-training, we don't naturally just get this planning ability.
Mm-hmm.
So like really the only solution seems to be collecting a lot of supervised data. I just wonder your thoughts on, is that true? Do you think that there is is that the only path forward for some of these tasks, is just to continue collecting a lot of supervision? Like, I have a secondary question. Why do we assume that LLMs are just going to be good at this? I mean, if they're just being trained on network prediction, why should we suddenly assume that they become planners?
Oh, I see. Yeah. So these are very good questions. So I think for the first question, I think I may have some kind of like answer in the later part of the talk. But I also think that maybe for the current stage, maybe what we need to do for especially for some like planning ability is that maybe we first need to collect some data to help them avoid the underfitting stage. Yeah, so I think this is a necessary step. Yeah, and after that, so after getting kind of like enough data, and we didn't see any like evidence like improvement, and then we can think about, okay, if there are any other kind of like interesting training methods to help the model to perform better under the same amount of data. Yeah, so I think so currently I think the main bottleneck of the agent training agent model is still the data. Is still about the data. Yeah, and so for your second question, I think because I think for the current like LLM based model, so they have already got very strong foundation like ability, like reasoning ability, something like that. So if we can use some like specific data, for example, specific to the planning ability, so I believe they can leverage their like own strong foundation ability to help us achieve better like planning, something like that. Yeah, I think it is also kind of like related to the alignment. Yeah, so maybe the base model doesn't have kind of like the base model is not trained for like the instruction following, but actually we need some like data to help them to use their foundational ability to really follow the diverse like the diverse user instructions. Yeah. So I think all of this because of the strong ability of the current base models. Yeah. you use ChatGPT for to extract like the steps and then the tools, and then you only have the last result. Do you think that you could actually ask ChatGPT to get the intermediate results? And then you could, I mean, some mistakes the model could make would be to like the last step is wrong, but others the steps in between were correct. So you still want to reward that behavior. So is there have you thought about doing that or kind of augmenting the labels?
Actually, we didn't we didn't do any of that, but that's a very good question. For example, maybe we can try to construct more data, based on this kind of principle. Okay, so I will go to the next part. Okay, so and actually, although we know that the Agent Lumos got very competitive results on the unseen task for web shop, and but actually the agent policy still relies on imitating the experience from the other tasks and environments to achieve better generalizability without any experience on the exact unseen testing environments. So why not just put the trained agent in the unseen environments to do some exploration and exploitation and learn from the feedback from the unseen environments? So, and then I will briefly talk about the two papers alongside this kind of dimension, which is called trial and error and Q-star agents. But I will talk it very briefly. So I will first, so we can first take a look at the trial and error work, which was also accepted at ACL 2024. So the overall pipeline is shown like this. So for the first stage, so as we did in the Agent Lumos, so we try to first collect some ground truth training trajectories from the exact unseen testing environment to learn how to predict the valid actions. But here I want to emphasize that because the training set size will be very small because we want to simulate a task scenario that will have kind of limited training resources. But here and also here we don't expect for this stage so the model can learn very good planning and reasoning ability because the training set size is very small. It is just for predicts the valid action. And then after the behavior cloning, or in other words, the imitation learning, so we put the trained agents to self-explore the new environment and sample the trajectories, which will result in bad rewards in the end of the exploration. So after that, so we got a bunch of trajectories which contain both the high quality ground truth trajectory, but it is a very small set. But also we can collect a lot of corresponding bad trajectories with reward. And then there will be a very intuitive reward. So actually, we know there's ground truth trajectory and bad trajectory. So we can do the DPO training, right? And then we can compose kind of some trajectory level preference pairs to do the DPO training. And this is for advocating the practical trajectory, but avoid sampling the wrong trajectories.
So for this, the correct trajectory comes from the small training set, or is this from the successful explorations?
It is from the explorations.
And so, do you train with the entire trajectory, or are you still splitting up the components? What if step 1 was correct, but step 3 is where the mistake happened, but both of them, let's say the incorrect trajectory makes a proper step 1, right? Will you still be penalizing that and hoping that on average it's okay, or how do you deal with that?
So actually for the behavior cloning, so because actually we have already got some existing
for the training phase.
For the training phase, I think for the training phase, so we have already got some ground truth trajectory, and also we do some exploration based on the current initial policy.
But I guess my question is, how do you know that incorrectly they don't care how the it's DPO, it's not staff DPO?
It's not step DPO, yeah. So we just input the whole like trajectories, the positive.
I think my question is still there, which is like when you're saying a trajectory is like not preferred, right? You're saying that mistakes will be during that trajectory.
Yeah.
Right?
Yeah.
So and you're comparing it to another one where you got the right answer, right?
Yeah, yeah.
So the claim you're making there is that one trajectory is better than the other. The question I'm asking is, what if the trajectory that got it wrong is almost completely correct?
Oh, I see.
Like, how do you know where the mistake is?
Yeah, so currently we didn't analyze the mistake, where the mistake is, and we also, we just use the entire trajectory, to do the very simple like DPO.
General RL problem.
Yeah, that's a general RL problem, I think. Yeah, but maybe for the Q-star agent, maybe it will be a little bit like relevant to the questions you ask. So we try to train like a process reward model to evaluate, okay, which kind of like action will be more optimal, something like that. Yeah. Okay, so after a round of like DPO learning, so the policy will become like better as they learn from some signals from the unseen environments. And actually we can do this iteratively, and we can collect another round of trajectory preference pairs, and also do another round of DPO training, and around like 2 DPO iterations. So we noticed that our method can bring very good like improvements on web shop, science board, and alpha board, which are all like unseen like testing environments. It can also based on like a very strong baseline, like the initial like SFT policy model, and also some further like preference optimization, for example, doing like SFT plus like rejection by tuning. And also we find that and also for I didn't put it there, but actually for some tasks, so the model can even beat the GPT-4. And actually, the core idea of the trial and error is to do the trajectory preference optimization, which implicitly learn which entire trajectory is more preferred. But actually, it doesn't. But actually, for the trial and error, it doesn't do any like process reward modeling, which will be super helpful for select the optimal action at a given like environment state. So I think for our Q-star agent project, so we propose a simple but effective method that only leverages the final outcome reward to provided by the unseen environment to model the process reward at each step. So in the first stage, I think I think it is very similar to the to the trial and error. So we will first do the behavior cloning with a limited set of training data, and then we will apply the policy model to do a very comprehensive like tree search to in the unseen environment to explore the environment and collect a lot of like experience. And then maybe there are some like trajectories which will really like finish the task. And for this trajectory, so there will be some like outcome reward scores. And then we will use that score to do the value back propagation to calculate the process reward at each at each tree node. Or in other words, so we name it like a Q value for each node, and for each node's value is calculated by the Bell-Manford equation, which is commonly used in the Q learning, and so I think the Q learning like value updating process will have super helpful to model the long-term utility of an action given the current environment. And after getting a round of like updated Q value for the tree nodes, so we can collect a lot of like state action at Q value tuples, and then we can use this kind of like tuples to train an individual like Q network, which is used to model the process reward. And after we get the QNet, so we can either use it to guide the inference time search. We can also use it to collect more higher quality like trajectories to do self-training to further improve the policy model. And actually here we find that okay, our QNet can also get very very good performance. So no matter we use it to do the we use it to guide the inference time search, or we use it to do the self-training to improve the policy model. And you can see that especially for the web shop, so you can even outperform the trial and error model by like around 5% improvement. Okay, so let's jump to the last section. Yeah, so this is not the end. So we also find some like other interesting directions that would be super important for building an adaptive like LLM agent. And next, I will provide some new perspective I'm working on right now. Yeah, and I hope it will do some like future research in this area. So the first perspective I'm thinking of is the efficiency of annotating the trajectories. So as I mentioned before, so if we fully rely on the humans to annotate the trajectories from the task beginning to the end, so the quality will be high, but the whole paradigm will be very costly and unsustainable. But on the other hand, so if the trajectory annotation fully relies on the LLMs to do the sampling, so the quality can't be guaranteed. So maybe we need to think of some like smart ways to combine the benefits of the human and machine annotations. And here, so after a few kind of like case studies, so we observe a kind of like a phenomenon. So we find that although the LLM agents may fail a lot of times in the final end when for example, to finish the task, but actually many intermediate steps can make it right, especially in the beginning part of the planning process. So if that is the case, so maybe an annotator just needs to provide some key natural language feedback or critiques in a few kind of like the key steps where the agent makes mistakes, and then the learning process would just let the models learn through this kind of like sparse learning signals about how to self-correct its behavior and avoid making similar mistakes. And here's an example. So the agent task to solve here is compare the time for walking and driving route from AMC waterfront to CMU. And the overall logic for the human is very easy. And also you can see that GPT-4 can also smoothly and correctly predicts the first few steps. For example, they know where to fill in the starting point information. They know how to fill in the destination information. But the problems then comes. So when so actually, in these steps, the model needs to realize, okay, I need to switch the transportation way from the car to the walk to really help us to do the final comparison. But although you can see that the agents know, okay, in this step, I need to switch the transportation approach, but actually they will finally go to some irrelevant like elements. Yeah, so yeah, but if at this time, if the annotators can provide some key like feedbacks or critiques to adjust the agent's incorrect behavior, so that would be a very very efficient supervision way to help to correct the agent behavior and let the agents to learn the correct planning process. Yeah, so for example, maybe in this stage, maybe the annotator can provide a key critique like, okay, the planning about switching transportation is really correct, but actually the element about work is highly likely to hide inside the car element. And then I will teach you, or I will teach the agent, okay, actually you should take a focus on the car element, and they are likely to contain the transportation like transportation approach information. And then so and after we provide this kind of like critique, so so the agent will adjust its behavior and finally do the correct planning. And actually, this is a very efficient like annotation process, because if you annotate trajectory from scratch to the end, so you need to allocate maybe 9 steps, for example, for the full task. But actually, for these tasks, for this task, you can see that we can just provide maybe 1 step, like a key, like critique or feedback to adjust its behavior. And for the rest of the parts, so the GPT model can already do it by themselves. So that will be a very efficient way. And yeah, so this is our ongoing project about the agent critique generation. So we want to collect a lot of like agent critique data, and we want to see, we want to use this kind of like data or kind of like agent critique data collection interface to collect multiple kinds of like annotations, like ground truth, full trajectories, critique data, stepwise binary preference, and reflection data to train a lot of like specialized modules to help the model to get better performance. Yeah, I will skip a lot of like slides, and I will talk about the last direction I may think is very important. Yeah, so previously I just talked about the agent critique, but I also think another direction which is important is about the word model or word simulator. So by definition, the word model is proposed to mimic the real world like environment state, and also models the state transition, the environment state transition. Yeah, and in many cases, for example, in embodied AI, so it is super hard to put an agent or a robot in the real world, everywhere. Right. So although everyone knows that the real world environment is very good, but actually the scalability is quite limited. So it might be necessary to consider some like LLM-based word models to diversify the environments and collect some high quality like trajectories from the virtual environments, and also then makes agents more generalizable and adaptive. Yeah, and also we did some like pilot studies to see, okay, if the LLM can really be a good like word simulator. And actually we find that, yeah, so for this page, you can see that this is the actual like GitLab repo page, and this is the generated like elements. The GPT model thinks one GitLab repo page should contain. So actually, you can see the elements here and there overlap a lot. Yeah, and also we do some like state transition like experiments. For example, I tell the GPT model, okay, I want to click on the issues element. So what will happen in the next state? And we also check the kind of like the element overlap. So we can see that most of the key elements are already covered by the generated like GPT generated elements. Yeah, and also so there are some other and the last thing is that I think the simulator can support more efficient iterative tree search for the agent task, which will not be practical to perform like a human study or involve huge agent environment communication overhead. So currently I'm focusing on the agent critique direction, and also the word model direction to see, okay, if we can get a lot of like useful data to further improve the agent performance. And later on, maybe I will focus on some like better like training method to further given the same amount of data to further improve the agent performance. Yeah, I think that's all about it. Thank you. Yeah, so if you have any questions too, so feel free to reach out to me. Yeah.
Yeah, thank you so much for your amazing talk. We are kind of at time, but we maybe have time for like 1 or 2 questions. Anyone here or Zoom participants, if you want to put it in the chat. What questions do we have?
For the agent critique part, I think it's really smart to only have human intervention when the model gets stuck. Mm-hmm. But how would the agent know that it's not grounding to the right thing? Or I guess you need some indication from the agent when it's unsupervised that it needs help at a certain point. So what are some strategies that how could agent know to ask for some intervention?
Oh, I see. Yeah, so this is a very good question. So I think for the current critique data collection, so I think there will be a human to monitor the whole planning process, and then the human can decide, okay, which time, when they will intervene the process and provide some feedback. And after we get this kind of critique data, so maybe we will train a critique model, and this model can automatically identify, okay, which time they should jump in to provide some feedback. Yeah, I think this is a very good question, and yeah, we plan to do it after we collect the data and to see how well the critique model will behave. Yeah.
So for the Q-style learning thing that you have planned, you will have to do likely some sort of epsilon greedy type exploration, right?
Yeah, exactly.
So what does it mean to take an epsilon action in the language model space, right? You just increase the temperature, or how?
I see. Actually, currently, yes, this is ongoing work. So we didn't do so currently we didn't do the epsilon grading search. Yeah, just the grading search. Yeah, but actually in the traditional Q-star method, so we need to kind of balance the exploration and exploitation. So
how do you have to make sure exploitation happens right now?
I think currently we are mainly about exploitation.
Okay.
Yeah, but we need to introduce some exploration. But another trade-off is that if we consider too much situation, so the search effort will be very large. Yeah. So so maybe the whole tree search will take maybe thousands of steps. So that will be super hard for implementing one round of experiments. Yeah. So this is a kind of practical issue why we didn't consider too much. Yeah, full exploration. Yeah.
Are there any other questions? Okay, we'll go ahead and wrap up. As a reminder, we are off from NL seminar next week for Thanksgiving, so I hope everyone enjoys the holiday. And then the following 2 weeks, December 5th, we will have Zihao He, who is here at ISI, and December 12th, we will have Becca Dorn, who is also here at ISI and was on the same EMLP outstanding paper that Jaspreet was on. So yeah, last 2 talks of the semester coming up, and thank you all so much for being here. Let's give Dala a hand.